Hi, this is Miss Oliva, and I'm going to go over properties of logarithms, and this is from 3.4. So first, we're going to just talk about basic properties of logs, and the first couple should be review from the last section. So one is that if you're taking the log of 1, no matter what the base is, your answer will always be 0. And that's because, again, of the exponent, that really means b to the 0. And b to the 0 is always 1, no matter what b is. The other one is if you have some base to itself, that will always equal 1. Again, because of the exponent way of thinking of it, b to what power would equal itself? 1. And then finally, the fun ones we talked about last time, where if you have the same thing here and here, that all just crosses out and you're left with the x in this case, and same thing here. That b raised to log base b wipes out and you're left with x. So these we have seen before. The new ones are that if you have the log base b of a and there's another power involved, that you can, and a lot of times should, bring that power out front, and it'll make it easier to do whatever you're trying to do to solve the problem. So a lot of these we're going to be practicing today, and you're not going to really know why, but when we get into the more complicated problems where we're solving, you'll see that sometimes you're stuck in this form, and knowing how to switch it helps you solve the problem. Okay, so one thing to remember is that you can bring that exponent out front. The next thing is if you're taking the log of more than one thing being multiplied, if you want, you can split it up to the log of the first one plus log of the second. So do you see how there was only one log in the beginning of both of these, and now we have split it up to log of this plus log of this. So it's kind of like distributing the log, but not really. But if you want to think of it as that, that's okay. So same thing here. I can make this log go to both the x and the y, but this time, because they're being divided, I just need to make sure I subtract them. So log base b of the top minus log base b of the bottom. So like I said, we're just going to practice doing this just to get used to the idea of going back and forth, but this will make more sense in the later sections when we're using it to solve complicated problems. So since this is log base 2 of these two things being multiplied, remember 8x is not just a term by itself. It's really 8 times x. So I can rewrite this log base 2 8 plus log base 2x. And before you finish, just check if either of those could be reduced nicely. When you have two numbers, think, because it might be reduced. 2 to what power is 8? Well, 3. So that means this whole thing that looks kind of weird can be rewritten just as the nice number 3. So you always want to do that if you can. This one has an x in it, so I definitely cannot reduce it right now. So this is as nice as I can make it. So make sure you get that this one has 3 different things being multiplied. So I'm going to rewrite it ln5 plus lnx plus lny. This, if I wanted to reduce it, I'd think e to what power gives me 5. That's not going to work out nicely. So we're just going to leave these as they are. Next one, log base 4 of 16 plus log base 4 of a. I'm going to try this one. 4 to what power equals 16? 4 to the second. So that means that whole first term is just 2 plus log base 4 of a, which I definitely cannot reduce without knowing anything about a. And finally, another division, which means I'm going to change it to subtraction, log m minus log n. Definitely cannot reduce those because there's no numbers. Okay, so a fancier one. This one we need to be careful because there was no shortcut or no way to change it if there was something being added. So I need to make sure I'm thinking of this whole top as one thing that's being divided by the 100 in the bottom. So I cannot separate the x4 and the y. They are stuck together. So I need to rewrite this log x to the fourth plus y minus log 100. And then this is the one I'm going to see if I can rewrite, which I can, because 10 to what power gives me 100? 2. So again, this first one cannot become any nicer, but the second one can become 2. Before we get into some of these with square roots and stuff, I want to make sure you remember that when you have a square root of x, you can rewrite that as x to the 1/2 power. So the fraction powers really mean roots, right? So this one that has a fifth root of x to the fourth becomes x to the 4/5. So the power is on top and the root is on the bottom. So when I see number 6, I'm first going to try to rewrite this. So this would be the same as p to the 3/7, because 3 was the power and 7 was the root. And then the only thing I can really do is that rule we haven't really done much with yet. And that is, since I have an exponent here, I can bring it to the front. Okay, same thing with this one. Nothing much to do, but there's an exponent. So that exponent can come out front. I can think about if this could become nice, but it can't. E to what power is 0.3? No idea. All right, now we're back to having some multiplication and division. There's just more going on here. So watch how I handle this one. Log base 7 of r to the third. I'm going to be able to do something with that 3 minus log base 7 of s to the 6. And then since this is also in the bottom, minus again, log base 7 of t. So the only thing left is these exponents can come out front. So 3 log 7r minus 6 log 7s minus log 7t. So you're going to split things up, and then if you can bring exponents out front, you want to do that. All right, next one's a little trickier because we have some roots and some parentheses. So I'm going to try to make this a little nicer before I start. So mn, since it has a fifth root, is really the same as mn being raised to the 1/5. And on the bottom, since both of these are being raised to the third, I can separate them, which means I can do the same thing to the m and the n. So both of these have a 1/5, both of these have the 3. So ln m to the 1/5 plus ln n to the 1/5 minus ln p to the third minus ln q to the third. And so hopefully you're getting the hang of this, that we're now going to move those exponents out front. 1/5 ln m plus 1/5 ln n minus 3 ln p minus 3 ln q. So I just was careful to kind of go through the inside as much as I could until I knew what each individual thing was being raised to. And that helped. So same idea with this one. This is ln of a bunch of stuff all being raised to the 1/7, right? Because it's all inside that root. And we have an n squared plus 2 on top. And don't forget, because of that plus, this is going to have to stay together. I'm not going to be able to separate them at all. And then I have the e to the 5th. So that is the same as the stuff on top raised to the 1/7. And the e, since it has a power, remember you multiply powers if you have one power raised to another power. You don't add them, you multiply. So 5 times 1/7 is just 5/7. So now I'm going to separate them. ln of all of this to the 1/7 minus ln e to the 5/7. We can bring the exponent out front for this one. But for the next one, I noticed that I have an ln and an e next to each other. So those just wipe out, and I just have the 5/7 by itself. Whoops, sorry. So I brought the 1/7 out front. And then here I noticed ln e was by itself or next to each other, so I could wipe them out and make it so that I only have the 5/7. So definitely take some practice understanding how to split these up. And now we're going to do the opposite. So now they're asking me to write the logarithmic expression as a single log. So here we have multiple logs being added or subtracted. So now we're going to squish them together as one log, remembering that you can change it to multiplication and division. So for number one, and they all have to have the same base. So these are all log base 10, since I don't see a number. So I can put these together. It would be log of the first one divided by the 6 and also divided by the 22. So I'm going to reduce that and see what that is, since there's no variables in there. I can actually do it. So 1320 divided by 6 and divided by 22. And I get 10. And log base 10 of 10 I can do. So my final answer after all of that is just 1. So that one worked out nicely. They will not all work out nicely like that. So when you're trying to put stuff together like this, you want to make sure they have the same base, which they do, log base 3, but you also want to make sure there's no numbers in the front. So again, we're doing the opposite of what we did before, and we're going to put that number in the front back to the exponent. Now I can put these together because it's log base 3 of the first thing times the second. Because they were being added, I can change them back to multiplication. So you see, we're just doing the opposite. On the last page, we started with something like this and we split it up into something like this. Now we're going the other way because it just depends on the problem, which one becomes helpful to solve. So you need to know how to do it both ways, so you'll have all the information you need to solve the harder problems. So again, I'm going to move this 7 to the exponent. I'm going to move this to the exponent. Remember that that really means root. And this to the exponent, which also means power and root. So this becomes log of x to the 7th over y to the 1/4, z to the 3/4. But we can even write that in a nicer way, because if both things on the bottom are to the something 4th, that means they both are under the 4th root. So I can write it that way. Y to the 1st power times z to the 3rd power. So because they both had a fraction with the same denominator, that means I could put them under the same root. So this is where I would stop. One more of those. I'm going to put this 1/4 to the exponent. No exponent here, none here, so we're good to start. We have log base 2 for each thing, so that's good. So we have x to the 1/4 times this x squared minus 4. And on the bottom, we have x minus 2. So just like how we see if we could reduce this, I kind of noticed there's something I might be able to reduce here. So I'm going to rewrite this. First of all, I'm going to make that a 4th x. And then I can factor the x squared plus 4 to x plus 2 and x minus 2. So then there's one thing I can cross out to make this a little nicer. So the final answer is going to be log base 2 4th root of x times x plus 2. Okay. Next problem is not hard, but it's just a little confusing to understand what they want you to do at first. So make sure you go through this with me. If they tell you specific values for things, so they're telling us that log base b of 2 is about this, log base b of 3 is about this, and 5 is about this. And they want us to approximate our answer. What that means is they don't want us to use calculator. Okay, so don't use your calculator if they're giving you these approximate values. What they want you to do is kind of view this as like a puzzle and say, all right, they're asking me for log base b of 20. They did not give me 20 and they don't want me to use my calculator. So what am I supposed to do? Well, you're going to try to figure out a way to rewrite 20 that would involve some of these numbers. Probably not going to be 3. 3 can't go into 20. But I could rewrite it with a 5 if I said 5 times 4. But I don't have a 4 either, but I have a way that I could write 4. So I'm going to change this to log base b of 5 times 2 to the second power, because that's 4. 4 times 5 is 20. So I have not changed the problem at all. I've just changed the way it looks. And now I'm going to use my rules we just learned to split this up to log base b of 5 plus log base b of 2 to the second. Remember, I can bring that 2 out front. And now I have things that they have given me up here. So apparently, according to them, log base b of 5 is about 0.835 plus 2 times log b of 2, which is 0.335. And I can do this. So it's kind of like a puzzle, rearranging what they gave you so that you can use the information that they gave you in the beginning. So that would be the final answer for that one. So maybe pause and try this one yourself. See if you can figure out a way to write 45 using only 2s, 3s, and 5s. And then see if you can finish this one. And then unpause me and see how you did. So I'm changing it to 9 times 5, which means 3 to the second and 5, which then I can split up with addition. And then I can bring the 2 out front again. So I just need to do 2 times whatever this is, which they gave me, plus whatever this is, which they also gave me. So 2 times 0.542 plus 0.835. Which is 1.919. Let's see how you did. Okay. Last one, I think, is this one, which is again just a very specific question. So let's see if I can help you understand this a little better. So they're giving us an example that for log base 2 of 3, if we wanted to estimate the value of this log, meaning we're not doing any math, we're not picking up our calculator, but I just want to be able to estimate right off the bat, what is this between? What 2 numbers is this between? The way you could do it is thinking of, so here's an example with log base 2, 7. that this is between 2 and 3 because 7 is between 2 to the second and 2 to the third. So the 2's came from this. So that's how we're comparing it. What exponent would I need so that 7 is between 2 to this one and 2 to this one? And it was 2 and 3 because this is 4 and this is 8. So for 3, I need to think what powers of 2 again is 3 in between. Well, 2 to the second is already 4. So that's too big. So I need 2 to the first power here and 2 to the second power here. So that means log base 2 of 3 is between the integers 1 and 2. So it's all about thinking about what exponents you would need given the base. Okay? One last rule we have not mentioned yet is the change of base formula. And that's when you have a log with a base that you cannot do in your head. It doesn't work out nicely. You can't say b to what power equals a. It's not nice. So for instance, log base 5 of 7. I'm stuck because 5 to what power equals 7? I have no idea. But there's this change of base formula that lets me rewrite this log 7 over log 5. And that will help me solve this. Okay, sorry, I just need to fix something that I noticed on the notes. So the way I just did it here is correct. So for here, make sure you write the formula correctly, that it's this number that goes on top and the base that goes on the bottom. So if this is log base b of a, it's log a over log b. That's the change of base. So just like I showed you here, log base 5 of 7, log 7 goes on top over log 5. And so this you could put in the calculator if you needed to. So get a calculator and approximate this to 4 decimals. So first you need to use the change of base formula to rewrite this log 3 over log 2. Make sure you do that carefully because most calculators are going to put a parenthesis here. So make sure you close it before you divide by the other one. So log 3, close your parentheses, divided by log 2. You should get about 1.58496, blah, 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 blah. So rounding it to 4 decimals is tricky again because we're stopping here, but the 6 is going to make us round up on the 9. So 9 goes to 10, which really means we add 1 to what was before it. So make sure you're okay on your rounding. So check using exponential form. Since this is about this, that means 2 to this power is about 3, right? I'm just rewriting it in different forms. So this is what we just found out using the change of base formula. And if we change the form, it would be 2 to that power is about 3. So you could check that out and make sure it works. So change of base formula, we haven't done much, but make sure you see that that's a way that you can continue for ones that do not have a nice answer. So you could put them in the calculator by using the change of base formula. All right, have any more questions? Please let me know before you get ready for your next quiz.